Hello friends, welcome again. Today we'll be solving a problem related to network analysis, and the problem is here we are given a circuit and we are asked to find what is the current flowing through the inductor at t equals to 3 seconds. Okay, so how to solve this question? Here you can see that the switch S1 and S2 are open for a very long time. Okay, and t equal to 0, S1 is closed, only S1 is closed, and at t equal to 2, S2 is also closed. So we are asked to find what is the current flowing at t equals to 3 seconds. Okay, so for these kinds of question involving RL circuit and DC source, okay, please remember RL with DC source. Okay, so this is a first order circuit, DC source. Okay, we have to keep in mind this formula. Okay, for current. Okay, this formula is I t is equal to I final plus I initial minus I final e power minus t by tau. Okay, where tau is equal to L by R, which is a time constant. Okay, so this formula must be kept in mind. So when a switch is closed at t equal to 0, so the circuit will look like this. Okay, here this S1 is the switch which is closed and S2 is still open, and the equivalent can be drawn like this. Okay, this is the equivalent circuit. Okay, this is the equivalent circuit. Now for this circuit, what is I final? I final will be the current which will be flowing when steady state is reached. So when steady state is reached, okay, this uh, inductor is going to behave like a wire, okay, or a simple conductor. So the current which is flowing at that instance I is equal to be I final. So this I final is equal to 10 by 5 is equal to 2 ohms, 2 amps. Okay, so this is uh, the current which will be flowing. Okay, I final. Now we have got our I final. I initial, as you already know, is 0 because no current was flowing before the switch was closed. Okay, so I initial was 0. So now I can write the expression of current. Okay, I of t as I final, which is 2 amps plus I initial, which is 0 minus I final 2 amps. Okay, e power minus t over tau is L by R, which is going to be 1 by 5. Okay, so if I calculate I of t, this is going to be 2 minus 2 e power minus 5t. Okay, now uh, I will calculate my current at t equals to 2 seconds, because that is the time when S2 is again closed, so dynamics will again change. So let us calculate the current at I equal to 2 seconds. So I equal to 2 seconds, the current is going to be 2 minus 2 e power minus 10. Okay, now if you calculate this, it comes out to be I of 2 is equal to 1.9999092. So it is nearly equal to 2 amps. So already we have reached a steady state, we can say like that. So at 2 seconds the current is going to be nearly 2 amps. Okay, so I can write it as 2 amps. So I of 2 is 2 amps. Okay, so now I of 2 is given, is known to us. Now what we can do is, let us see what happens when we close S2 also. So when you close S2, okay, so this 3 ohm gets bypassed because the switch will have a very low resistance pass, and the circuit is shown here. So this is going to be my circuit now. So now you can see here that many things have changed. Okay, again we will apply the same formula. So here I final is going to be the current which shall flow when steady state is reached. Okay, so this is 10 volts and 2 ohms. Okay, so this is going to be I final. Okay, which is going to be 10 by 2 is equal to 5 amps. Okay, now this current 5 amps is flowing. Okay, now 5 amps is the I final current. Now what is your I initial? I initial is going to be the current which was calculated at 2 seconds. So I at 2 seconds, which was nearly 2 amps. So this is our I initial. Now we can substitute these values here. Also our tau is going to be 1 over R. R is now 2, so it's going to be 0.5. Okay, so you can see everything has changed here. Now one thing you need to keep in your mind is what should be instead of t. Now instead of t, you should substitute it with t minus 2. Why? Because this is happening at t equals to 2 seconds, and this equation is applicable from t equals to 0, not t equals to 2. Okay, so you have to substitute t with uh, t minus 2. Okay, okay, so when we do that, what we get here is I of t, okay, is equal to I final. I final is 5 amps plus I initial. I initial is 2 amps minus I final is 5 amps. Okay, e power minus t over t minus 2. Okay, instead of t you have to write t minus 2. Okay, by tau. Tau is going to be 0.5. So now you get I of t is equal to 5 minus 3 e power minus t minus 2 into 2. Okay, so now what you can do here is you can find your current at I equals to 3 easily. I at 3 is equal to 5 minus 3e minus 3 minus 2, which is going to be 1. So this is what we get into 1, because this t equals to 3, 3 minus 2 is 1, so we get this as the value. So if you calculate I at 3 seconds, so this is going to be simply 5 minus 3e minus 2. Okay, now if you calculate this, it comes up to be 4.593 amps. Okay, so this is the answer that we get. So current at 3 seconds is going to be 4.593 amps. So this is how you can solve this question. So thanks for watching.